Good afternoon. My name is Jos. I have been speaking to you via the courses of the Introduction to Aerospace Engineering, and we have seen a lot of comments from your side. It's very nice to see them all, and a few of comments, questions, I would like to have a very few explanation to it, a few answers. One of the questions you asked was about thick and thin wings. Next to me is a large wing, a thick wing. You can see here that's the upper skin and the lower skin. You see the web plates, and this is a rather large skin, as you can see. Reasons for such a thick skin, so a thick wing, are, for instance, the aerodynamics. That's one of the reasons. Also, Professor Hoekstra told you about it. But also, as you can see, you can have much better structures. So you can take up much easier all kind of loads and forces. And in the third place, you can also see that you do have, and this may be a little bit difficult for you, but it's very dark inside, because the interior of that wing is coated with a special coat. And the special coat closes all crevices, because the interior of that wing is also used as a fuel tank. You can imagine that you do have a very large volume if you have thick wings. That's opposite if you go to thin wings. So I step to this side. And here you see, for instance, the wing, a short one, of a fighter jet. And the wing thickness is in this case that large. So there's not many room here for fuel. Fuel has to be stored on different places in such an aircraft. Also, structural and systems are much more complicated. As you can see, for instance, here, with the movement of this aileron, you can see we need to have special systems, special devices to be able to move those. That's much easier if you do have a thick wing. The second question we have got was about pioneers. Some discussion might be there that are the Wright brothers the real first ones who flew with a heavier aircraft in a controlled way, etc., etc. Realize that during those days there were a lot of pioneers in many countries. You had, for instance, Blériot, you had, for instance, Otto Lilienthal, you had, for instance, Santos Dumont. Those were all kind of people working on aircraft and lighter than air aircraft, as well as heavier than air aircraft in those days. And particularly in the first decades, there were a lot of claims of other people who said, well, this was our invention and that was their invention, etc., etc. Nowadays we believe that the Wright brothers were the first one who taught us how to fly with a heavier than aircraft in a very controlled way, movable and with powered engine. The third question was about the drag coefficient. Drag coefficient, which you can write down as CD, is a constant value, CD0, plus a induced parameter. An induced parameter has connection with our lift coefficient, as you can see. Besides the lift coefficient, there are also two other parameters in there. First is the slenderness of the wing, which can be defined as B, the wingspan, divided by the average chord of the wing. And this is what we call the Oswald factor. And the Oswald factor is a efficiency parameter, and that relates the slenderness of the wing, or the shape of the wing, with a pure elliptical shape of a wing. Well, just to show you, this is, for instance, a very low value for A, and this is, for instance, a very large value for A. This is a very slender wing, and this is not a very slender wing. So this has a very low A value, and this has a very large A value. Now, if you compare such a wing with the more elliptical wing, then you can also derive what the Oswald factor is. Usually that factor is in the order of 0.7, 0.9. Well, and further you see, of course, that there is a relationship between the drag coefficient and the lift coefficient in a squared manner. Well, that's also can be explained if you look, for instance, at the lift drag polar CL CD. You see more or less such a curve, and there you can see it is some kind of parabola, and that's also reflected in these two combinations.